Good afternoon, everyone. Thank you for joining us. I'm Becky Anderson, and I'll be presenting the strategies for science safety to the group today. I ask that you kind of bear with me a little bit. This is our first one, so I want to make sure that it might be a little bit rough, so please bear with me. Give me a little grace. But we're going to go ahead and get started. We've got a lot of information to cover today. So let's go ahead. Oops, I need to screen share too. Apologies for that. There we go. All right, let's go ahead and get started. Okay, so first of all, I'm Becky Anderson. I've worked with some of you before, and I look forward to working with more of you in the future. I've been a hazardous materials chemist for about the last 25 or 30 years. I did a stint as a volunteer firefighter for a little while too, but predominantly my career has been focused on risk minimization and identification of risky chemicals. And one of my most important and my most favorite jobs has been in helping schools understand the risks associated with the chemicals located in predominantly science classrooms, also art rooms, industrial technology, and also maintenance of facilities areas. I've worked with schools in Iowa. That's where I live, and that's where my business is focused. However, I've also done a lot of work across the country nationally, and I've also done a little bit of international training. So I'm hoping that we can provide you with some excellent information today. I do want to take just a minute and thank Vicki Davis of the Upper Valley Lake Sunapee Regional Planning Commission. That's a mouthful, but Vicki is the one that applied for the grant and got the funding in line so that we could present these to you. These will be recorded today, and they will be on the same website, Hazardous Materials Consulting, that you use for registration. So you're welcome to go back and reference them again. I'd also just like to take a quick minute to thank all the folks from EPA Region 1. They're the funding providers for this, and they have been outstanding in helping us get prepared. Finally, a lot of the resources today were developed by Dave Waddell. Dave Waddell was with King County, Washington, and ran a Rehab the Lab program for several years. He's been retired for a few years now, and he's one of my mentors in this area. He was absolutely outstanding when he was working with us and training a number of us. And so I just wanted to make sure that we acknowledge Dave's efforts. He provided us with fantastic resources. Goals for this webinar series. I want to make sure that we help you identify and minimize the risk in your classrooms. We get questions specifically answered. You're welcome to type in questions into the question and answer area. The chat is not open at this point in time. At the end, we'll spend the last 30 minutes going through question and answers. I also want to share with you what we have seen across the country so that if you do find yourself in one of the challenging situations of having a whole stockroom full of legacy chemicals, to know that you're not alone and that we have developed some pretty good solutions for this. And I believe that we can really develop a customized plan for your facility to help make sure that those legacy chemicals are eliminated and we minimize risk for the teachers, other faculty members, and our students. And then we're going to offer as many resources as we possibly can so that I don't want to reinvent the wheel here. We've got a lot of great resources that have been developed over the last 20 years. If you have some technical difficulties, these are some technical tips from EPA for the Zoom webinar. Again, one of those things, if you have questions that come up, please type them into the question and answer box, submit those, and we'll try to get to as many of those as by the end of the presentation as possible. All right, I'm going to go ahead and shut off my camera, and we're going to get started on topics for today. Okay, so first we're going to go through a quick history lesson. Where did these legacy chemicals come from, and why are certain chemicals designated as legacy chemicals? Have we found them throughout the nation? Have we found them in specific school districts? And then what are tools you can use? What are some of the deciding factors that you can use and implement when you go into your stockroom and you determine whether or not you have some of these legacy chemicals present. And then finally, I want to make sure the emphasis today is going to be on recognition of highly hazardous legacy chemicals. One of the things that we have identified, and this has been across the United States, is that there are frequently legacy chemicals that have become so old and unstable that they are potentially shock sensitive, friction sensitive. They can get angry and explode just by picking the container up and moving it. And we absolutely want to keep you safe. So we're going to go through and identify some of those today. I'll cover as many as I possibly can. One of the other things that I wanted to take a minute and let you know also is that hopefully you're watching this. The information that I'm going to share with you today is our best practices and the regulatory compliance requirements to the best of our knowledge right now. Please keep in mind that as we learn more, as we find more things, sometimes guidance changes. Over the last 20 years, we have had to change a little bit of guidance here and there. So if you're watching this in the year 2055 or something, know that this material was created in 2024. And right now it's current for the times, and it's the best of our information that we have right now. All right. One of the things we're also going to focus on is, and this is going to be kind of a mantra throughout all of our webinars, is the acronym RAMP. And that stands for recognize, assess, minimize, and prepare. And what we're going to be focused on is recognizing those highly hazardous chemicals, identifying either how to dispose of them, or assessing, is there something else we can use instead of those high risk chemicals, minimizing our risk and our exposure as much as possible, and then preparing that if we do have to keep something that's fairly risky on site, for example, a concentrated acid, how are we going to prepare in the event that we have an emergency with that chemical? Okay, legacy chemicals are actually those chemicals that were manufactured typically in the 1940s and 50s. And the reason that we see so many of these in school districts throughout the entire country is that we were at that point in history, we were in a space race. And the Soviet Union at that time put up Sputnik, and the United States fell behind in the space race. And there was a lot of angst and anxiety, and also a lot of heavy focus on, we need to get our science programs beefed up. And so I had one old professor several years ago that told me, oh yeah, we got a Mallinckrodt catalog, and we were told, order one of everything, whether you think you might need it or not. Well, a lot of our science teachers did at the time, of course. And what we're finding is that we still have many of those chemicals sitting on shelves, and they've never been used. And in fact, as I've done this and gone through different school districts, we've actually found those original chemicals still with the plastic rings on the top of them that they haven't been opened. So those are what constitutes legacy chemicals. And we see that, again, these are at colleges, universities, high school labs. We also see them at some labs through consolidation that will have, like, some of them will show up in a K-12 lab. So that's what we define as legacy chemicals. One of the ways that you can, this is one of the most helpful ways that you can determine whether or not you have legacy chemicals on site, is to take a look at the labeling. The labels will show if they've got a block Mallinckrodt label, and the vast majority of the legacy chemicals were from Mallinckrodt. And what we see is that we'll see that the block lettering in the hexagon from Mallinckrodt, and that has not been used by the company since the 1960s. If you've got the old script Mallinckrodt label, those haven't been used. That labeling style has not been used since the 1950s. So we're talking some pretty hefty age on these chemicals. Chemicals were not manufactured to last on shelves more than about 10 years. And some of them significantly less than that. So this is a problem. Also, if you've got any containers, the old brown bottles that have corks in the top, we haven't used corks to seal up chemicals since the 20s and 30s. We also occasionally will see old cardboard containers that have what I call paper hats on the top of them. That's the only type of lid that they have. Those are also from the 1920s and 30s. And then I've also given you an example of an old Welch label. The Welch Chemical Company hasn't been around for a long time. That one's from about the 1950s. So one of the things that you can do is to go into your stock room and just start looking at the labels. Now, when I tell you that, I'm going to ask you to put your hands in your pockets when you first go in and start taking a look around. Before we get into the rest of today's presentation about what are the dangerous chemicals, I want to make sure that I emphasize to you, we've got to make sure we're staying safe while we're looking for these legacy chemicals. Because again, there's some bad players that can be hidden in the back or hidden amongst the other chemicals that you are using. The Rehab the Lab program, that was the name that King County came up for this type of program. There was a huge emphasis that started in Washington State and it continued in the Midwest in the early 2000s. And it was led by the North American Hazardous Materials Managers. There were a number of conference leadership that were very involved in this, predominantly Dave Waddell. He trained a number of us to be able to go out, identify legacy chemicals, identify the high-risk ones, and then we started building state by state individual processes for getting rid of those chemicals. To date, in Iowa alone, we've removed more than 525,000 pounds of legacy chemicals, 525,000 pounds. And through that process, we also conducted, we had unstables in about 100 schools that we had to conduct on-site detonations to happen. To manage those, we worked with our bomb squad on those. We also found DEA controlled substances, and we found things like radioactives, source radioactives, and Geiger counters both. So the legacy chemicals are the predominant focus for today's webinar. And then what we're going to talk about in the next webinar is once you decide you have legacy chemicals, what are the things that you're actually going to keep and continue to use? And then we'll talk about some strategies on how to get rid of legacy chemicals. Resulting from this chemical stockpile, we've seen a lot of problems over the years, just due to the nature of the chemicals themselves. The containers have become very unstable. Probably the tipping point in Iowa where we really started paying attention to this was when we were alerted by the primary insurance carrier, EMC Insurance, that they had had a property loss in Kansas that was directly the result of improper old chemicals sitting next to each other. A school teacher went to move them from an old school to a new school, boxed them up. The chemicals began to leak over a weekend. They caught on fire and they burned, caused $600,000 in damage to the old school. Luckily, they were still in the old school and they weren't in the new one. This prompted EMC Insurance to become heavily involved in Rehab the Lab. So what we're going to talk about the rest of today is determining if you have those legacy chemicals. And we want to make sure that we keep you safe. We want to do a very concise evaluation of chemicals to see if you have legacy stockpiles. And we're going to be laser focused on 4 criteria for disposal. I get a lot of questions, or I've had a lot of questions over the years on, well, how do I know whether or not I'm going to need something? And one of the things I'm going to encourage you to do is really stick to your guns on this 4 criteria methodology to select what you keep and what you dispose of. We want to replace anything that is an old legacy chemical that you are using. We want to refresh those chemicals. We just can't rely on the integrity of chemicals that have been sitting around for 50 and 75 years with multiple teachers in and out of them through the years. So we want to replace those with small quantities. And one of the things that I found in working with teachers is that science teachers in particular, and I'm a chemist at heart. I mean, that's what I do for a living. And I love chemicals and I love working in science and I love working in chemistry. And what I found is that we can often develop almost an emotional attachment where it's almost painful for us to get rid of this kind of stuff. What I'm going to tell you is once you work through this process, and you end up with chemicals that you know are safe, that their integrity is good, that their quality is good, and you've minimized the shelf space needed in your stockroom, you're going to be really happy about this. So it does take a little bit to get through it, but know that we've had great success in many, many states in getting this done. Before you all get excited and go back to your stock rooms and start moving things around, again, I'm going to ask you, when you go into the stock room next time, keep your hands in your pockets. One of the things what we want to do is make sure that we're not putting ourselves at risk. So we've got to start with recognition of hazard and assessment of those chemicals. We're going to do a visual inspection only of that stock room. We're not going to start moving stuff around right away. We want to do a visual inspection. We also want to evaluate the labs that you're doing to see and make a match between what you need to keep and what you're currently using. And what you'll find is there's usually a lot of stuff on the shelf that's not being used. One of the things that we'll do through this series of webinars is also offer some training on EPA regulations and hazardous waste regulations. That's webinar number 3. And I want to make sure that we're doing things right, both in Vermont, New Hampshire, and then any of the other states that have joined us as well. We're going to focus on when we do recognize legacy chemicals. We have to remember that those chemicals have been sitting around on the shelves for 50 to 75 years. Nice, quiet, sitting in the back, not doing anything. Finding them is not an emergent situation. It does not warrant evacuating the school and calling 911. What we're going to do is we're going to use a very methodical, metered approach to getting rid of those legacy chemicals that are dangerous. To begin looking, we've got to make sure that you're minimizing your exposure as much as possible. So this afternoon, or whenever you go into your chemical stockroom next, again, hands in the pockets, we're going to do a visual assessment. One of the first things that I want you to look for is, or look at, is how are those chemicals stored? Are they on the shelves in alphabetical order? Or are they on the shelves by chemical compatibility class? Those two pieces of information will give you a lot of insight as to how things have been used and managed, how chemicals have been managed over the years. One of the things that we know is if some teacher along the way had moved things and started storing them by chemical class, we know that we're in a less risky situation. If we still have chemicals that are stored alphabetically, we're going to see some additional added risk just because there are certain chemicals that when they're stored in alphabetical order, we can see some interactions. So that's the first thing that I want you to observe and pay attention to. Also, if you have any things like if you have low ventilation in your chemical storage room, or you have some flammable cabinets or corrosives cabinets that are in your chemical stock room, we want to make sure that we're minimizing our respiratory exposure. You do not want to be breathing those fumes in. We want to minimize that as much as possible. So one of the things that we usually encourage teachers to do, or anyone that's going in to evaluate for legacy chemicals, is to open those up, open the windows in the classroom, and create some ventilation. We want to minimize your exposure to those vapors as much as possible. The next thing that we want to do before we start really working to recognize if we have legacy chemicals on site is we want to make sure you're protecting yourself and your coworkers. This is not an exercise to do alone. You want to make sure that you're working with someone. We want to open up ventilation as much as possible and pay attention to vapors and particulates. And if you really feel like there's something going on that is causing you headache, dizziness, nausea, any of those types of things, that's a sign that your body is saying you need to leave the area now. Okay, so we need to pay attention to that. I also want to make sure that you're working in good personal protective equipment. So we want to wear a lab coat or a lab apron. We want to use nitrile gloves. Even if you've picked up the bottle 100 times and there's nothing on the outside of it, please put a pair of gloves on, disposable nitrile gloves, before you handle those chemicals. We just want to make absolutely certain that we're not exposing ourselves. We want to have either safety glasses or goggles on. Goggles are the preferred eye protection, just because they will also protect you from vapors. Safety glasses are acceptable if you're not going to be working around organics or solvents. But again, goggles are really the preferred. Excuse me. We want to make sure that we're using nitrile gloves, not latex gloves. We also want to make sure that we're wearing long pants and that we have our legs covered and our feet fully covered. I would also encourage you to make sure that you have a spill kit and an emergency plan. One of the things that we found is a lot of these containers are very brittle. And if we do go to move them, it's not unheard of for the bottles to crack. So we want to make sure we have a spill kit that's readily accessible, fire extinguisher, and we want to make sure that your safety shower and eye wash station are in working order. So you might want to talk with your maintenance folks about that before you get started on this. Additional things that are very helpful, an intrinsically safe flashlight. What that means is a non-sparking flashlight. It's specially designed. You can get them off of Amazon for about $10 to $15. So they're not a very big expense. But an intrinsically safe flashlight will help make sure that we don't add any sparking sources. You'll also probably want a camera. Your phone camera is fine, but a camera to take some photos of what you're dealing with. Fan for ventilation, and again, full personal protective equipment. As we're looking and assessing chemicals, we want to make sure that we leave them in place. So again, hands in your pockets, you're just using your eyes, you're doing a visual assessment. Once we get through this and you've identified if there are any highly hazardous legacy chemicals, then we can work strategies to move chemicals around them out of the way, but we always leave the high hazard legacy chemicals in place. We do not want to move them and consolidate them to another shelf. We do not want to move them and give them to the maintenance department. We don't want to move them, stick them in a box in your trunk and then drive them out to someplace and never mind. I don't want to go there, but we do not want to move those off the shelves. All right. The next thing we are going to do is we're going to establish the criteria for what you're going to keep. And we'll talk more about this in the next webinar. But there are 4 criteria that we're looking for. Number 1, are they highly hazardous? Does the risk exceed the utility of this particular chemical? And we'll get into the details as we go along in the presentation of what these highly hazardous chemicals are that we need to watch out for. The other 3 criteria are ones that have worked in several states, and they essentially take the guesswork out of deciding whether or not something needs to be disposed. The first one is that chemical greater than 5 years old? Now, this is a rule of thumb, okay? This is not a black and white definitive rule, because we have some chemicals like copper chloride. Okay, copper chloride doesn't degrade. It usually has a really nice long shelf life. Not much messes with it or interacts with it to cause a problem. So if we have a bottle of copper chloride that we've been using for 8 or 9 years, that's okay. That's one of those ones that we don't worry about it as much. But a general rule of thumb, if you've got a container that's greater than 5 years old, those are ones that you'll want to put on the disposal list. Okay. And again, if it's a stable container, if it's sucrose, not a problem to let it go to about 10 years. But we have some that will become much more unstable with time. So 5 years rule of thumb. If it's older than 5 years, we're going to put it on the disposal list. The other one, the next criteria is greater than a 5-year supply. And in the next webinar, we'll spend some time calculating that and showing you how to determine what a 5-year supply looks like. And then the last one is unstable, broken, or leaking chemicals. If you become overwhelmed, so you walk into your chemical stock room and you've got 7,000 bottles in there. First of all, know that you're not alone. All right. This happens a lot. I've been in many, many, many schools over the years, hundreds of them, that have had to face this legacy chemical or excess chemical problem. We will find some solutions for you. It might just take a little more creative thinking. If you do become overwhelmed, start one shelf at a time. That's the easiest way to do this. Start one shelf at a time. If you find any of those high-risk legacy chemicals, again, we're going to not touch them. We're going to leave them where they're at. They are not an emergency unless something makes them angry. We're going to talk about now, on the next slides, we're going to go through these specific examples of high hazards. I want you to know that this is not an all-inclusive list. Okay, it's not possible for me to lay out all of the high hazard chemicals that we've seen. We're going to hit the ones that we most commonly see. Okay, if you are not sure if something is highly hazardous, but you have a gut suspicion, if something's triggering in the back of your head and saying, you know, let's just not mess with that one, stop what you're doing, take a little time to do some Google research. Safety data sheets from my favorite company is Sigma to get the safety data sheets from. They're comprehensive, they're very well done, and they do very definitively define the different risks associated with chemicals. So pull a safety data sheet out and evaluate chemicals. The other one, the other source, if you need to go more in depth about chemical risk, is PubChem. And if you need more information about that, let me know. But otherwise, PubChem is another resource database or resource bank that has a lot of very in-depth information about chemicals. Now, the key classifications of high hazard legacy chemicals that we have found, we're going to start with the ones that are potentially explosive. These are the ones that have formed peroxide crystals in them or have the potential to form peroxide crystals. There are also ones that when they dry out, such as picric acid, when they dry out, they become extremely shock sensitive and explosive. Again, if we see these, if we have these in our stock room, we're going to leave them sit where they're at and we're going to make a note of it. Not an emergency issue, not an emergency, unless we have somebody that mixes it up, picks it up, starts moving it around. Next class of chemicals that we're going to talk about are the water and air reactives. We have a number of water reactives that we see throughout the United States, and those water reactives can also form peroxide crystals. Not a whole lot of folks are familiar with that, so we're going to spend some time on it. Next category is acute toxins. These are things like cyanides, sulfides, things that if we mix them incorrectly, we can end up with dangerous or even deadly vapors, fumes coming out into a classroom. We're going to look at containers with integrity risks. So which ones have broken caps, which ones have crystallization on the exterior, anything that's broken itself out of its container. Finally, we'll look at DEA controlled substances and radioactives. While we don't run into a whole lot of those, I'll give you a heads up on the ones that we have seen. Okay, peroxide formers. This is the category of chemicals that is most risky, in my opinion. Okay, peroxide formers are those chemicals, they're typically solvents. They have a shelf life of anywhere from about 3 to 18 months, and that's the maximum, even if they have an inhibitor in. So one of the things that we've noticed is, even if you purchased in 2010 a container of ethyl ether, if you're doing Drosophila experiments or using it as a solvent, that ethyl ether has used up its inhibitor within the first 18 months. It is no longer shippable. It is a DOT violation to ship those over the roadways if they are unstable. So we've got to handle it a different way. If it's older than 18 months, we want to leave it in place, make a note of it, and work with our local emergency response teams to get rid of that. We do have some recommendations for and guidance for New Hampshire and Vermont on working with the bomb squad. If we do come across things like this, key thing is leave it in place. It is not an emergency, and we want to work with our local emergency responders to handle it. One of the things I want you to see, to note on the slide, the very center picture with the little short rusty can with the little plug in it, that little plug is actually a hunk of lead. And those types of containers were used for ether, ethyl ether storage. And it was thought that, well, if we put the lead plug in there, it's going to prevent peroxides from forming. We know now, after 50 years, that that is not the case. We can have peroxides form under that cap just as easily as the photo in the top left, which is a newer ethyl ether can. Those peroxide crystals can form under the cap. The challenge with ether is we can't see the peroxide crystals. That's the same challenge that we run into with other common peroxide formers: cyclohexene, tetrahydrofuran, styrene, acetaldehyde, metallic potassium. All of those are peroxide formers, okay? And we can't see when those peroxides have formed. What we have to do is we have to recognize that these are old containers, these are peroxide formers, and there's a, let's just say, a high likelihood that there are peroxide crystals under those caps. We do not want to pick those up. We don't want to move them around. We don't want to unscrew the cap. We don't want to look for the crystals. We're going to let those sit where they're at, and we're going to handle them through our emergency response team. Typically, the bomb squad will come in. They'll do an exercise where they have a chance to do training in a low stress environment. They'll do it on a weekend when there isn't anybody around. They'll remove those, but they'll don their bomb suits. They'll put them in containers, carry them out of the building, and then typically they'll put a small charge on them and detonate them on site. I want you to make sure, though, that you understand and hear me clearly. These are not chemicals that we want to pick up and move around. These are very unstable, or have the potential to be very unstable. And again, there's no way just in looking at them for us to determine that. Next one, the next class of chemicals that are also unstable are dinitrophenols, things like collodion, things like sodium peroxide. The easiest way to find a list of chemicals that are peroxide formers is to go to Google, type in list of peroxide forming chemicals. It'll pop up a number of different choices for you. And then one of the best options is to use a resource from a community college, a college or a university. Frequently, their safety, health, and environmental folks have put together guidance on how to use these on campus. Same thing applies to you. So that will give you a good list of chemicals to, as you're doing your visual inspection, evaluate and recognize as high risk. In biology, we've changed a little bit. In biology, what we're looking for are nitro-organic compounds. So dinitrobenzene, dinitrotoluene, dinitroaniline, those are some that we see a lot. We also will occasionally find picric acid or Bouwen's fluid. Bouwen's fluid is actually made with picric acid. Both of those, when the picric acid crystals are allowed to dry and crystallize, recrystallize again, if they're not suspended in liquid, they become extremely, extremely shock sensitive as well. This is an example of one of the on-site detonations. So this is 80 pounds of sandbags were put over a 1 pound container of dried picric acid. The picric acid was then treated with a charge by the bomb squad, and you can see the level of detonation that occurred here. Anytime, there were probably only maybe 5 to 7 schools that I've worked with over the last 20, 25 years that had dried picric acid that we had to manage this way. And I will let you know, those were those detonations, and the ethyl ether detonations were the most violent. Very large ethyl ether will also create a very large fireball because it is a flammable solvent. The picric acid isn't a flammable solvent, but the concussion from the picric acid detonations is really robust. We saw a lot of unstables at a number of different schools. One of the other ones that comes up a lot is solidified sodium azide. And of course, we have all of the things like methyl methacrylates, collodion. Those are all chemicals that when they sit around long enough, they create instability in the containers themselves, and they can actually blow the containers apart on your shelves. If you do find that this has happened, leave that area alone. One of the other tricks that we found to be able to read labels in the back, if you use your intrinsically safe flashlight and then you use a mirror, frequently we would put the mirror towards the back, hold the mirror up over the chemicals towards the back, and that would give us at least some way to identify and evaluate those chemicals that were in the far back shelves. The next class of highly hazardous chemicals that we occasionally see are water reactives that have formed peroxides. And I see a lot of teachers conducting demonstrations using metallic sodium, metallic potassium. Okay, cool stuff. Definitely fun stuff to play with in the lab, as long as we're using it in very, very small quantities and we're keeping it separated from students. The problem though is when we see old legacy chemicals like these, if those metals, both the potassium and the sodium, and we can add lithium into this too, occasionally we do see lithium, those need to be that pretty whitish silver color and they need to be stored under oil. If they've been sticking up over the top of oil, or if they're a different color, if they've turned red or orange or black or have spots on them, all of those are indicators that this is no longer metallic sodium, potassium, or lithium that we're dealing with. That material has changed. And if it's yellow, orange, or red, those are super, super reactive chemicals and are also shock sensitive and friction sensitive. So far we've talked about ethyl ethers, a number of other peroxidable chemicals, and now we're talking about the sodium and the potassium and lithium that have formed peroxide crystals as well. If you run into this situation, again, this is one where we want to leave this container in place and work with our local emergency responders. Detonation of these materials is really kind of you have to have a funky process. These are elemental, so we can't just blow the outside crust off of them and then let them sit all off of all out in our front yard or anything. We've got to make sure that we're reacting those chemicals off. So this usually requires coordination between the bomb squad and the fire department. So we have the bomb squad that helps detonate them and remove that peroxided crust. And then the fire department comes in, flushes the area with water to react off those water reactive metals. Next one, and we have not run into this a lot, but I definitely wanted to give you a heads up on it. And for some reason, between this and the sodium and potassium, I don't know, I always seem to find them stored in old peanut butter jars. I have no idea what that's all about, but we definitely saw a lot of them. This is yellow and white phosphorus. This is extremely air reactive. Typically, these are stored underwater. The problem is they're almost always stored in glass containers. If we drop that glass container and that that phosphorus starts reacting with air, it's going to light itself on fire, and then it releases the toxic gas phosphorus pentoxide. So we've got acutely toxic vapors leaving the air, and we've got it, and it burns hot enough that it would go through a cement floor very, very quickly. So we've got to be really careful with this. This is another one, although it's not a shock sensitive chemical, a lot of times we find it in containers that are old and that are have become unstable over time. So we want to make sure that we're not messing with these. Also, if you find any red phosphorus is a different type of phosphorus. It is not as reactive has yellow phosphorus and white phosphorus. It's not an air reactive. It does react with air, but not explosively, not and it doesn't create a big fireball. However, red phosphorus is no longer allowed in schools or in general industry. It's actually on the DEA registrant list of chemicals. So unless you have a pharmaceutical license or you're a DEA registrant, you're not allowed to have red phosphorus any longer. We were running into too many problems. It's a component in meth manufacturing. So we were running into too many problems with that. So we want to pay attention to that as well. Know that red phosphorus, excuse me, is another one that you're going to contact your emergency response for some assistance with. Same thing with the yellow and the white phosphorus. All right, next category that we need to talk about. These are not shock sensitive water or air reactives. However, these do present significant risk to everybody. These are the acute toxins. These include potassium cyanide, sodium cyanide, and sodium azide. Okay. Please note that I said potassium and sodium cyanide, not the ferro or ferrous cyanides. That's a different class of chemical, much less risky. We still have to pay attention to it. We still want to minimize the amount we keep on site, but the really bad ones, the bad players that we've got to pay attention to are the potassium cyanide and sodium cyanides. We need to get those out of the school district. Sodium azide for a long time has been used as an antifungal in things like agar. I'm going to encourage you, if you want to use something like that in agar to make sure that your agar doesn't mold, buy the pre-mixed kind. They come in very low concentrations. And instead of mixing up your own in tiny concentrations, it's just not worth it. The exposure to sodium azide is really dangerous. Now, this is an interesting list of chemicals. And I want you to know that, again, these presentations are being recorded and you'll be able to access this. But if you have any questions or you'd like a list like this, you'll have my email at the end of the presentation today. And I'm more than happy to help you understand what are considered toxic chemicals or bioaccumulative chemicals. These are also typically, not all of these, but typically these are the ones that are heavily regulated by either your Department of Natural Resources, Department of Environmental Services, or the Environmental Protection Agency. These are ones that if you are using any chemicals that have, or any compounds that have antimony in them, arsenic, barium, beryllium, cadmium, chromium, lead, nickel, selenium, or silver. All of those are ones that are toxic. We've got to pay attention to minimizing our exposure and our students' exposure to them. And they absolutely cannot go down the drain or in the trash for disposal. So one of the criteria that we're going to talk about next time in our next webinar is, as we're deciding what chemicals, I know we have a lot of folks that are using sodium chromate, potassium dichromate. We also see a lot of folks that are using like silver nitrate, those types of things. One of the things you've got to consider as we're looking at these lists and as we're identifying chemicals for disposal is, are these chemicals that you do you want to have to collect them when you're done with a particular experiment? Is there an alternate experiment that you can do that doesn't use that chemical? If you do have to use it, if it's an AP class or something like that, I fully understand. We've got to use chemicals to make good scientists, but we want to make absolutely certain that we're collecting those and that we're managing them properly. So we've got to build you out a network of how to do that. All right, next, additional toxics. We're seeing a lot of mercury all over the place. Mercury wasn't on my last list. I kind of stick that in a category of all of its own, because mercury compounds are so incredibly expensive to get rid of. So mercury compounds, mercury thermometers, we really want to get those out of the schools if we possibly can. And in fact, I don't know of any experiments that are still being done with mercury. It's just not, it's one of those chemicals that's just not worth working with. The other one is fulminates. Fulminates, if you do run across mercury fulminate, That is an explosive chemical. I have not seen it in 25, 30 years of doing this, but I did want to give you a heads up on that one. All right. And then finally, if we've got integrity concerns, again, we're going to leave those containers where they're at, but we're going to take a picture of them and we're going to make a note of them and the size of the container. If we can figure out what's in the container, that would be very helpful for the hazardous waste disposal companies. But otherwise, we want to note those and note where they're at. Container integrity is a really big problem that we've observed in a number of different places. And the last thing that I want you to do is disrupt any of those containers, especially the ones that have crystals on the outside. The first photo on the left here that shows the arsenic trichloride, pretty fluffy little crystals. They look like they're super cool. One of the things I wanted to show you though is these, that I see crystals like this on the outside of the container and man, I want to mess with them. I'm going to tell you, do not do that. Fight the urge, okay? This is an example of arsenic trichloride crystals and the OSHA, the permissible exposure limit that OSHA says it's okay for you to be around in an 8-hour day is 0.01 parts per million or milligrams per meter cubed. 0.01 parts per million. Those are so small that even a tiny, tiny amount is going to impact our health. So we've got to pay attention. If we see crystals that have formed, we want to leave them where they're at and not mess with them. DEA controlled substances that we've seen, and we don't see these very often, but we have seen them. Things like thorazine, chloral hydrate, adrenaline, also testosterone, cortisol. Occasionally we'll see those left over from old biology experiments. Those are also ones that we just no longer use those in any experiments. So we need to have those removed from the schools as well. And then final class of chemicals that we see are radioactives. Again, we don't see them very often. Typically, if we're going to find radioactives, they're usually in the physics department. A lot of times they'll come in a big old yellow wooden box that was distributed in the 1950s by the Civil Defense Corps. They went to a number of facilities throughout the states, distributed giant boxes that had Geiger counters and sources in them. We really no longer have a need for these. A lot of these sources have become, they're usually not in in strong, robust containers any longer. So those are ones that we also need to dispose of. So if you have legacy chemicals, you go into your stockroom this afternoon and you're looking around, you're doing your visual assessment, you're recognizing what the different hazards are and you're assessing what the risks are. And all of a sudden your head starts to ache and you go, oh, wow, we've got a lot of problems here. We've got a lot of legacy chemicals. Keep in mind, we don't want to move them around because of the integrity of the containers and the potential for some of them to react. What we're going to do next time is we're actually going to talk about a flipped strategy for managing this. What we're going to encourage you to do is assess the chemicals that you are using and move the chemicals that you are using if they meet the 4 criteria, if they're less than 5 years old, if we have less than 5 years of a supply, if they're in good container, have good container integrity, and if the risk doesn't exceed the utility, those are chemicals that we can continue to use. And we'll take those chemicals and we'll actually move those chemicals into our shelves where we're going to begin to start sorting them by chemical compatibility class. We want to leave the legacy chemicals in place as much as possible. In New Hampshire, thanks to Vicki, we've been working with Maine. Oh, Vicki, what's the name of the place? I can't remember the name.
Maine Lab Pack.
Thank you, Maine Lab Pack, and they have offered to assist in inventorying chemicals for disposal for a certain number of schools in New Hampshire. They've also let us know that they work with a number of schools in the Northeast. They've got a series of states that they're able to go into. And I would suspect that if you sweet talk them really nice, they will help you get through this process as well. They have in-depth knowledge of this problem. They've assisted a lot of schools, and we're happy to help connect you with them so that you can take advantage of their expertise and assistance. The next, the next webinar will be identifying the chemicals again that you're using currently, making sure that they meet the 4 criteria, and then rehoming them to an area of your stock room where we can start sorting them by chemical compatibility class. So over the next few days, we're going to focus right now on risk and recognizing and assessing risk. And the 5 things that I'm going to ask you to do is to develop an inventory of what you use, not what you want to get rid of. That can be very overwhelming. Make a list, an inventory of what you use. If, as you go in and do your visual assessment, and you start looking for some of those categories of chemicals that we went through that are high hazards, whether they're shock sensitive peroxidizable chemicals, they're water reactives that have been sitting around too long, they're air reactives, or they're acutely toxic, or the containers have integrity problems. If you find any of those, again, leave them where they're at. We don't want to make them angry. List them, identify them to your administration and your colleagues so that no one goes in the area and messes with them, and then keep them locked up. Please make sure they are locked up in your stockroom. Remind the folks that you're telling, this isn't an emergency as long as we don't mess with them. If we mess with them and they become angry, then it's an emergency. Then we've got to do the whole call 911 and evacuate the school, and nobody wants that. So identify them, assess the level of risk, alert those around you. Don't share this information with students, even AP students. I have over the years had a few teachers that like to tell stories to students about what creepy things they found. I'm going to ask you not to do that. This needs to be kept confidential. And then please schedule to attend our webinar next week, where we talk about identifying the things that you do use and how we can, and the 4 criteria that we're going to use to select those chemicals. Now, I actually got done a few minutes early, so we're going to go ahead and answer as many questions as we can. This is my contact information. Handouts and resources will be, hi Heidi, it's good to hear from you. I will be putting handouts and some additional resources on the Hazardous Materials Consulting website. Okay, so the website that you used for information or for registration rather, there will be some additional resources. I'm not quite there yet. I actually am meeting with my web guy next week, and we're hoping to get a number of resources. Also on the website for the upper, Vicki, can you tell us what your website is?
Well, we're working on our website too, but it's Upper Valley Lake Sunapee Regional Planning Commission.
Yeah, and there are a lot of exceptional resources out there already. You kind of have to dig along and look through things. But if there's something in particular that you're interested in also, you're welcome to email me, and I'm happy to help find any resources that you might need to use. Okay, do we have other questions today? I want to, before we jump into more questions, I do want to make sure that I take the time to say thank you for spending the time today with us. I know this is hard to get out of an hour of school during the school day. We very much appreciate it. And we're hoping that we can help you evaluate the risk and minimize it as much as possible in your science labs and then also throughout the rest of the buildings. So we've got a whole series of webinars coming up. Please, please feel free to join us. All right, did we have any other questions come through? Thanks, Heidi.
I don't see any
Okay.
other questions, Becky. Maybe
Nope. All
anybody
right.
have a question for Becky?
All right, fantastic. And if anything comes up as you're going through stuff, you're welcome to send over an email. I'll work as hard as I can to get you information that's helpful. You're welcome. Yeah, silver nitrate's one of those ones. We love to use it. It's really super handy. And there are some tricks that you can continue to use it. We just have to make sure that we're not dumping it down the drain or throw it in the trash. So it is an EPA regulated hazardous waste. Okay, do we have anything else? Thank you. Really appreciate everybody's time today.
I think we're good, Becky. Thank you so much. That was wonderful.